अब बच्चों आप ट्रांसपोर्टेशन की गल कर रहे थे. In transportation today we are going to discuss the transshipment problem. Basically it is related to the time component. Earlier whatever we have discussed cost related component. Here in this problem we are considering the time to be the major component. Basically this problem is very important in case of the military operation. When we are going for a military operation or the country is going for any type of war situation, the time is more important as compared to the cost. So here in this type of problem, we have to give more emphasis on the time instead of looking into the cost. So basically, there is a problem. Basically, a military equipment is to be transported from origin. The military equipment has to be transported from the origin to the destination. Basically, there is a 3x4 matrix which is given to us. There are 3 origins, there are 4 destinations which is given to us. There are 3 origins, 1, 2, 3. There are 4 destinations, 1, 2, 3, 4. 1, 2, 3, 4. And here, this is the time component. It could be minutes, it could be hours, or it could be days, and even we can go with the years also or the months also, but it is better in a war-like situation. It could be minutes or hours by which the equipment has to be transferred from the origin 1, 2, 3 to the destination 1, 2, 3, 4. So look at the problem. How to solve this problem? We are going to discuss this. This is also known as the transshipment problem. This is the problem which is given to us. This is a time component 20, 12, 10, 15. This is given to us. What is the supply from the origin? What is the supply from the origin? 1. This is the supply. 8, 13, 11. If you count it, this is 32. If you count it, this is 32. What is the demand? Demand at destination 1, 2, 3, 4. It is given. This is 5, 11, 8, 8. And here if you look at here, demand and supply is matched. Once the demand, this is basically a balance problem in a transshipment. So look at this problem. Do the allocation according to the northwest corner rule. In this situation, it is better you should go with the northwest corner rule because we have to find the quick results. When we are going with the northwest, this is the north, south, east, west. This we have already discussed. Find out the initial basic feasible solution related to this one. This is 5 here, this is 0 here, this is 3 here. This has been exhausted, and here it is maximum allocation which can be made 3. This is 0 here, this is 8 here. So this row has been exhausted, and here it is, this is 8, this is 0, this is 5. This has been exhausted. This is 5 here, maximum allocation, this is 0 here, this is 3 here. So this second row has been exhausted. This is 3 here, this is 0 here, this is 8 here. This has been exhausted. This 8, this is a 0, this is 0. So all rows and column has been exhausted. So what is the solution we got? This is the movement. This is the movement. Now we will go with the optimality test. Here we are not going to perform UV method or modified distribution method. Something else is required. We will discuss that thing here. Here we have to look for a more logical part. I am going to discuss that thing here. Let us write down the values here, because here time is more important as compared to the cost. So we are not going to calculate any cost here, or means how much the country or a party has to invest in this one. This is not important, because in a military operation the movement of material is more important. 5 means we have to supply the material within the minimum time. This is 3 here. Basically this is the allocation this is 8 here, this is 5 here. Clear? This is 3 here, this is 8 here. Your demand and supply has been matched. This is 8 here, 5 plus 3, this is 13 here, this is 11. If you look at it, this is given to us, this is 5 here, clear? This is 11 here, this is 8 here, this is 8. Clear? Now, the maximum value here it is 22, means 22 minutes, 22 hours or 22 days. What could be, you can measure with respect to time. Now, here this 22 has to be reduced. Put a cross here. When you are putting cross here, if you look at here, this 22, we have to reduce this one. Look at here, if I make a loop here like this one, if I make a loop like this one, here it is plus, here it is minus, here it is plus, here it is minus. Now here, when you are going to do the allocation here, now here it is, this is 3 is here. Now this is 0, 3 and 5, the minimum value is 3. 3 minus 3 is 0. Here it is added, 3 plus 1 is 11. Here it is minus, this is 2. I put it here, this is 10 here. I look a refined solution here. This is crossed. Here it is 0, means the allocation is 3. Allocation is 3. Here it is 22. We put a cross here. Why? Because if you look at here, we are able to reduce 22 days or 22 minutes or 22 hours, whatever the time component you are going to measure. If you are considering this to be 22 hours, we are able to reduce by 2 hours so far, because allocation has been up to 20 hours. Now here it is. Now we will try another effort. Now here it is. Let me write down here. This is the allocation which has been made. If you count it here, this is 8 here. It satisfies here. This is 13 here, 11 plus 2. This is 3 plus 11. Is 3 plus 8, sorry, 11. Here it is 5. This is satisfying this demand. This is 11. Destination D1, D2, D3, D4. This is 8 here. 3 plus 2, 5 plus 3, 8. This is 8 here. Again, this is 32, 32. Now we are going to reduce, now we are able to reduce by 2 hours. If we are considering this to be a time component in terms of the hours. Now we are going to reduce, we are working on a 20. This is the next least value. After 22, the next least value is 20. Now work on that one. If I give the allocation like this one, here it is plus, here it is minus, here it is plus, here it is minus. What happened here? This is minus, plus, minus, plus. Now do the allocation. When we are going with the allocation part, look at the allocation part. Look at the allocation part. This is the loop which is there. Here it is 11, here it is 3. The minimum value is 3. This has to be, here it is will be 3. Here it is 0. This is 0 here. Here it is 2 plus 3, this is 5. 11 minus 3, this is 8. Now whether it is going to satisfy this one, look at here. This is 5. Put a cross on this one. Why? Because again, by default, if we are able to do the allocation, means if we are considering the again 22, then instead of reducing, we will go with the other direction. This is 8 here. This is 12. This value is 5. This is 8. This is 20. We have reduced this one. This is 12. The allocation is 3. This is 10. This is 15. The allocation is 8. Look at here. Look at here. Now here it is again. This satisfies whether demand and supply. This is 5 plus 3, 8. This is 13. This is 11. This is 5, 11, 8, 8. It must be satisfied. If it is not satisfying, something went wrong. But here in our case, it is perfectly okay. Now again if I do the allocation, there are 3 corners where there is a allocation. Basically you get a loop like this one. Here it is plus, here it is minus, here it is plus, here it is minus. When you are doing the allocations here, look at here. Basically, here it is 8, here it is 8. Both are getting reduced. Means here it is 0, 8 minus 8 is 0. Here it is 3 plus 8, 8 is 11. Here it is 8 minus 8 is 0. Here it is, this 8 has been shifted here. Now look at the allocation. What the allocation we are getting after doing this iteration? 22 put across here, because we are able to reduce the 22 hours to the 20 so far. In next iteration, the iteration which we are performing, this 20. Here there is no allocation, means there is no shipping of material from origin O2 to destination D2. This is 0 here. This is 12, the allocation is 5. Here it is 8, the allocation is 8. And here it is 20, this is reduced, this is reduced. This is 12, this value is 11. This is 10, this is 15, the value is 0 here. So don't do the allocation here. And here if you look at here, this is 8 here, this is 8 here, this is 13, this is 11. It is satisfying our this supply of the material from the origin O1, O2, O3. Similarly, this is 5 here, this is 11, this is 8, this is 8. This is also satisfying demand at destination D1, D2, D3, D4. So if you look at here, when we are doing this, we are able to reduce by 22 to 20. Both has been cancelled out. There is no allocation at 20. Now 15 has also been, next lower is 15. Automatically by default, there is no allocation on 15. Now we are left with, we started with the 22 hours and we have reached by 12 hours. Means we are able to save 10 hours during the military operation. Now we can't further reduce it because there is no allocation, though there is no loop which is available. So this is the best result. We started with the 22 hours in the matrix, and we have reached up to 12 hours. Means there is a shipment of material from in a 12 hours. This is the 12 hours. There are 2 locations, O2 to D3. If you look at here, the interpretation of result, O2 to D3, 12 hours, and O3 to 2, again 12 hours. So we started with 22 and we have reached by 12 hours. Means we here in a military operation, we are able to reduce 10 hours, which is a wonderful result. So this is basically a problem of transshipment. Here in a matrix, the values are in time component. So that's it from my side. If you have any question, thank you very much.